All right, welcome back to ABA exam review and a continuation of our BCBA task list 5th edition series where we're continuing with D3, identify defining features of single subject experimental designs. So we're continuing on our experimental design task list. So start to build on these foundations that we're establishing as we move towards the actual designs. So today we're going to talk about serving as their own control, repeating the measures, and then baseline logic. As always, check out behavioranalyststudy.com for all of our study materials, including our combo pack and practice exams. When you pass, let us know so we can include you in the Sunday shout out. Work hard, study hard. Let's get going. So, single subject designs are the primary method of experimentation in ABA. Almost never do ABA practitioners use group designs. So what is the difference? Well, in group designs, let's say you have a group of 50 and then another group of 50. And what you would do is you'd give one group a certain intervention, and that other group would be, let's say, the control. They wouldn't get an intervention, and you'd compare the groups. Single subject designs, however, the subject or participant is their own control, meaning you are comparing their own baseline to their own interventions and to other interventions. So as we change conditions, as we go through phases, as we give interventions, remove interventions, we're comparing all the changes to that participant to all their past behavior. So they are their own control. That's what we mean by single subject designs. What it does not mean is that there's only one participant, although there can be. So for example, in practice, you typically work with one client at a time. So if you're using some sort of design, you're going to have a single participant, which is fine, but it doesn't have to be only one participant. Typically, you're going to get 3 to 8 participants, and designs like multiple baseline designs should ideally have at least 3. So don't let this name single subject confuse you and make you think it only means I can have one participant. All it means is that participant is their own control. We're going to compare their baseline to other interventions. I'm going to go keep on comparing as we go through that design. Because ideally, in a perfect world, you'll take baseline, you'll do an intervention, you'll remove the intervention, more baseline, do another intervention, because you're looking for functional control. Are we manipulating the DV? Are we controlling the DV? And we're trying to control for extraneous variables and confounds. That's what single subject design is characterized by. So quick question, what is meant by single subject design? A, there is only one participant in the experiment. Well, we know that's not necessarily true. There can be, but that's not what we mean by single subject. B, there are a large number of participants. We know that's also not true, right? We're not using a large group design here. C, the participant is their own control. Yes, that's what is meant by single subject design. The participant is acting as their own control. So, what are some actual characteristics of these single subject designs now that we know what they are? We have at least one subject with at least one behavior, to be our DV, and at least one setting with at least one intervention, which is our IV. Simple as that. And then we have to have a way to measure the behavior. So very straightforward, right? Single subject designs are often a lot simpler to execute compared to group designs. You have, say, 1 to 8 participants, each as their own control. You're manipulating one variable at a time. And so it's a lot more controllable. It's a lot tighter than, let's say, these big group designs. It's very important to systematically arrange and manipulate variables because we try to avoid confounds and demonstrate control. And we're about to talk about baseline logic here, right? Which involves steady state strategy. So again, single subject designs, one subject, one behavior, one setting, one intervention, measure. And let me clarify, right? At least one subject, at least one behavior, at least one setting, at least one intervention, and then we measure, okay? Again, anywhere from, let's say, 0 to 8 or 1 to 8 is pretty typical for single subject designs. You're going to introduce your intervention, try to manipulate or control the DV, and then we're going to measure. So how are we going to start identifying if we're effective? Well, let's talk about baseline logic. Baseline logic begins with steady state strategy. Steady state strategy is repeatedly exposing a subject to a condition to limit extraneous variables. And so what do we mean by that? Well, we want to achieve steady state responding. So let's say we have baseline that looks like this, right? Obviously, it's all over the place, but there's a lot of variability there, right? The baseline is jumping all around. You ideally want a very stable baseline. And then when you do an intervention, you also want that fairly stable, okay? So if you look down at our graph here, you can see our baseline, very stable, treatment gets stable, baseline stable, treatment stable. That's what we mean by steady state strategy. And through steady state strategy, we can use some baseline logic. So first, we're going to make our prediction. The prediction is the anticipated outcome of future measurements if we were not to change anything. So let's look down at our graph. We have our baseline here. Let's assume we don't change anything. What is our prediction? Well, our prediction is right here. Okay, our prediction is that the baseline would stay the same, everything else held equal. Now, following that prediction, okay, we're going to have to verify that those levels would have continued if you didn't introduce or change anything. So you can see we've gone from baseline to treatment and then back to baseline. So where is our verification? Well, right here, because we verified that had we not introduced treatment, our prediction is correct. And then we have replication. So repeating the introduction or manipulation of the IV, observing similar outcomes. So in treatment 1, right, we introduce our independent variable, and what happens? Well, the data shoots up. We then withdraw it. So to replicate it, we've got to go to treatment 2, introduce IV again, and here we have our replication. So that's what it looks like. And keep in mind, this is a AB design, okay? This is what we mean by steady state strategy. We're achieving stable data paths, and then we're predicting right here. We're verifying, and we're replicating. And this is how we know, okay, where we're trying to establish experimental control, okay, over our dependent variable. And when we can predict and verify and replicate and start to guess and be correct on what's going to happen with our data, that's when we know we're controlling for all these other variables and that we're controlling the experiment. So that is single subject experimental design and the defining features. That's the easiest part, okay? You have to know these fundamentals as we move towards actually using single subject designs, okay? Because we're going to talk about all the different designs moving forward. Make sure you know D1, D2, and D3 very, very well, okay? And then move on to the subsequent videos. Even D4, right, which we might gloss over or might combine, okay, because D4 really encompasses all the other designs, okay, the advantages of using the different designs. So what we're going to do is we're going to combine those advantages and disadvantages into the actual designs themselves. But you'll see that in the coming videos. So make sure you get D1, D2, and D3 down, and then we can move forward with experimental design and then go to the next video. As always, check out behavioranalyststudy.com for all of our study materials. Let us know when you pass so we can include you in the Sunday shout out. Work hard, study hard, like, subscribe. We'll see you soon.